The Pest and Predator podcast is brought to you by Field Heroes, powered by the Western Grains Research Foundation. Visit fieldheroes.ca to learn how beneficial insects can benefit your farm. Welcome to the Pest and Predator podcast, featuring interviews with entomologists from across the prairies. I'm your host, Sean Haney of realagriculture.com and Real Ag Radio on Rural Radio 147. And in this podcast, we're going to talk about some of the latest information on pests that you may encounter in your fields and the beneficial insects that help to control them. Today on the Pest and Predator podcast, we're joined by Dr. Jim Tansey. He's a pest management specialist with Saskatchewan Ministry of Agriculture, and Dr. Meghan Vankosky, research scientist, field crop entomology with Agriculture and Agri-Food Canada, based out of Saskatoon. We're going to talk about how pests and their natural enemies respond to weather and how that can affect pest population density. You know, Meghan, I've been doing these Pest and Predator podcasts now. This is the third season, and we always talk about, you know, the relationship of an insect and then the beneficials working for you for free. We've never applied the variable of weather. It's a and I'm kind of astounded as to why we haven't done that, because it actually plays an incredible role in some of the populations.
Absolutely. In the last few years, we've had some quite extreme hot and rather dry conditions across a lot of the prairies. And so we've been asked quite often in the last few months about the potential implications that these hot and dry or drought-like conditions could have on insect populations. So we thought it'd be very interesting to take this opportunity to talk about the complex relationships that insects have with temperature and with rainfall, and how the impacts on the pest might not actually line up well with the impacts on their natural enemies, like entomopathogenic fungi or the parasitoids that can play such an important role. So yeah, we have a couple of different insect species we'd like to talk about where they either have very contrary reactions or responses to these abiotic conditions, or where abiotic conditions really don't matter.
Yeah, and Jim, we're going to talk about a number, like Meghan says, we're going to talk about a number of different, very familiar insects to everybody here in the audience. Now, are the rules between the weather variable and the populations, the density of those insects, are they hard fast, or is it just something to be aware of?
Yeah, they're ectotherms. So, I mean, they are subject to temperature, and I mean, all aspects of their development and their activity are subject to temperature. And as Meghan alluded to earlier, I mean, entomopathogenic fungi are strongly influenced by relative humidity and moisture. And I think a really important consideration, we'll talk about this in some detail in a little while, is that not all insects respond the same to specific weather parameters. So some are real heat lovers, some not so much, and we'll talk about that in some detail in a bit. Yeah,
very cool. It has to line up for both the insect and the beneficial that's working for you, right? Like that's the really, really interesting part here. Okay, let's get to some of these insects and learn a little bit more. Okay, Jim, let's start off with grasshoppers.
Okay, I guess an important consideration when we're talking about grasshoppers on the prairies is that the bulk of the animals that are called grasshoppers are not in fact pests. In the case of Saskatchewan, we're really only looking at 4 major species that are pests. These include the Packards, two-striped, clear-wing, and migratory grasshoppers. And where temperature is important for these animals, I'll talk about 3 of these in particular. For clear-wing temperature, they're all ectotherms. So that is, they all rely on the external temperature for their development and activity. In the case of the clear-wing, they really like it warm. So maximum egg production, about 32 to 37 degrees Celsius. So they like it quite warm. Migratory grasshopper, upper temperature threshold for these ones, 45 to 46 for all instars. So these ones really like it warm. For two-striped, they like you'll see with a lot of these animals, they will actually bask to increase their internal temperatures, and they'll maintain body temperatures between 32 and 38 Celsius throughout most of a day. So you can see how the potential for warm temperatures like we saw last year might have implications for these. How this pertains to natural enemies is a little bit more complicated, but you can see with this greater potential for activity and input for grasshoppers with these warmer temperatures, they have the potential to increase greatly, and where natural the interaction of natural enemies and temperatures becomes really important for grasshoppers. This is most pronounced with some of their microbial or pathogen natural enemies, and some of these like Entomoptera grillii can be very important for reducing their populations, and that's a fungal infection, and that tends to be more prevalent in cooler, moister conditions. An important consideration with Entomoptera too is that there are different isolates that are more important for different species. So you can have one isolate that can do a real number on clearwing grasshopper that'll have a marginal or negligible effect on two-stripe and vice versa. So those isolates can be very important. So that interaction of weather and temperature and the isolate of those particular natural enemies can be important.
Yeah, because when I think of grasshoppers, I think of hot, dry weather, like in the depths of July. But so if we're going to have that natural predator, we need to have that to happen earlier in the season.
Not necessarily. I do have some firsthand experience with clearing grasshoppers being knocked down later in the season. So that is adults being killed in large numbers by an Entomoptera outbreak in a population there. And the times there were characterized by hot, sticky days in the afternoon. This was a couple of years ago in southeastern Saskatchewan. For those who remember, that summer was characterized by some pretty hot, sticky conditions, particularly in July. So that is, formation of thunderstorms and that sort of thing. And that really contributed to those Entomoptera outbreaks.
Very interesting. Okay, Meghan, let's talk about wheat stem sawfly.
Sure. Yeah. So like Jim was just saying with grasshoppers, the populations of grasshoppers respond really well to heat, and their natural enemies do okay in heat, but they prefer wetter conditions. So wheat stem sawfly are a little bit different in that there's really no clear known impact of high temperatures on the development of wheat stem sawfly populations, but hot, dry conditions can have quite negative impacts on populations of their natural enemy, which is a parasitoid called Brachycephy. Brachycephy can have 2 generations in a year, but if it's hot and dry, then crops dry up sooner, and Brachycephy only has 1 generation. So then we only have 1 generation, or half of the number of parasitoids perhaps, that are parasitizing wheat stem sawfly larvae, and over the course of a few years, this can mean that wheat stem sawfly populations can grow because they're not being controlled as effectively by their natural enemy.
So, Jim, when we look at pea aphids, how does the weather impact the beneficial that tackles them?
Well, it's twofold. Pea aphid is, as I mentioned, for grasshoppers, they really like it warm. Pea aphid, not so much. With those ones, their development is restricted at higher temperatures. You're going to see really high juvenile mortality, around 27 Celsius. So about 9% survival of juveniles at that temperature. So those warm temperatures, like we saw last year, can have a really profound effect on their population growth. They tend to like it cooler, so 15 to 20 degrees. Where I talked about the effect of temperature on them, and there's also a temperature effect on at least one of their natural enemies, and some of the work has been done on an invasive ladybug species. So the only thing that we can firmly say is about that one, but there is a potential for other interactions with other generalist predators as well. And in that case, the activity of that natural enemy actually increases with warm temperature and will increase right into the 30s. So you got the munchers of aphids increasing their activity and increasing their effect on populations, while the aphids are suffering with those hot temperatures.
Meghan, what about wheat midge? How does the weather impact that situation with its beneficial attacker?
Well, wheat midge is an interesting situation. And we've heard a few interesting situations so far today. Wheat midge themselves are dependent on moisture cues early in the growing season. So they overwinter in larval cocoons in the soil. And if we get moisture, precipitation at the right time in the spring, then those larval cocoons they'll come out of the cocoons and they'll move closer to the soil surface, they'll finish their development, and they'll pupate. And then, of course, we'll see the adult wheat midge emerge and have an impact on our crops. Well, the big impact of precipitation in the wheat midge system is that rainfall in the spring that actually will lead to the development of a wheat midge outbreak, potentially. So the natural enemy, Macroglenus penetrans, is also a parasitoid, and its life cycle is really tightly linked to the wheat midge life cycle. So the larvae overwinter inside the larvae of the wheat midge, and so then their development continues with those moisture cues as well. So the two, the wheat midge and its parasitoid in this case are very tightly linked together. So if we have conditions that are right for wheat midge, the conditions are very likely to also be good for Macroglenus penetrans.
Now, Jim, my understanding is with lygus bugs, humidity plays a role.
It does, absolutely. Under conditions of high relative humidity, they can be influenced pretty strongly by fungal pathogens, and there are a couple. But this relationship between high relative humidity and fungal pathogens can be pretty strong with these animals. It's important to note too that lygus is a genus, so it's a complex of about 6 species in the genus Lygus, and they generally tend to prefer warmer as well. Another influence of humidity, and I guess a byproduct of humidity, is rainfall, and this can have a significant impact, especially on young Lygus. So if you imagine you're the size of a Lygus nymph and you're struck by a raindrop, that could be a pretty profound experience. So, I mean, they can be knocked from the plants into the waiting arms of other natural enemies on the grounds, or suffer from drowning or other direct sources of mortality of that physically being knocked off the plants.
So, Meghan, we've covered a lot of ground here. What about the Diamondback moth? Is there any info on that one?
Well, actually, what Jim was just saying about lygus leads quite well into a discussion about diamondback moth, at least in part. So diamondback moth are a migratory species. They disperse into Western Canada in the spring, and the earlier they arrive and the hotter it is, the more generations they can have in a growing season. So this is a species that can have multiple generations quite close together in that growing season, thinking up to anywhere between 3 and 5, or maybe even 6 if they get here early enough and it's hot enough. But things like precipitation can interfere with that. The larvae, the caterpillars of diamondback moth, are quite small. They initially feed inside the leaves, but then they move to the outside of the leaves, and big rainstorms can knock them to the ground or have similar impacts as to what Jim was talking about for the lygus. So some of these abiotic or weather events can help to impact diamondback moth populations, both positively and negatively. But there are also a number of different parasitoids that can attack diamondback moth across Canada. Some of those parasitoid species overwinter here, but others don't. And so depending on where the diamondback moth population is and which of its parasitoids are present or not present, we can see some impacts of those natural enemy populations on the diamondback moth populations as well. Kind of a complex story. Again, there's a few different parasitoid species that can be quite effective. Some of those parasitoids actually migrate in with diamondback moth, and others are local residents. And those local residents have a bit of a leg up when it comes to having an impact on diamondback moth.
So, Jim, taking all this into consideration, on the Pest and Predator podcast, we always talk about the scouting, and not only scouting for the pest that's attacking our crop, but also the beneficial. So if you take all this information and translate it to the scouting and looking at your thresholds, connect the dots there for us on things we need to be considering as it applies to the weather and these insects.
Oh boy, yeah, that's a mouthful. I guess I can talk a bit about in the case of aphids. I mean, their populations are sometimes influenced greatly by the effect of parasitoids. Much like Meghan was talking about, there are parasitoids that are specialists, some in the genus Ophidius, and these can have profound effects on the populations of pea aphids. So one thing to be really aware of is when you're scouting is to scout at multiple times in close succession. So what you're looking for, is the mummies associated with those parasitoids, so you can get an idea of what kind of establishment of those parasitoids are occurring, and what sort of potential effects might be occurring. And one thing you want to do is look at the counts of your aphids in these close succession monitoring periods. So if you're seeing an increase, then your natural enemy complex probably isn't having the desired effect. If they've plateaued or you're actually seeing a decrease, then you can actually come to the conclusion that your natural enemy complex is having a significant effect on those aphids, and you may want to hold your fire on spraying.
So is what you're talking about there is like, okay, if I'm going to go out on a Monday morning at 7 a.m., go out Tuesday morning at 7 a.m. and Wednesday 7 a.m., not 7 one morning, noon the next time, and like 4 o'clock in the afternoon the next day.
Yeah, I don't know that time of day would have a significant effect on that. I think if you're out there in daylight hours, you're going to get comparable results, especially with aphids. But I think sampling over a series of days like that, not weeks, but pretty close succession in days. Okay, so a really important consideration when making decisions for pest control or the application of pest control products is temperature. And you'll see with a lot of the label recommendations, there will be a maximum temperature associated with efficacy, and you'll see that primarily with the group 3 or the synthetic pyrethroids. And these are subject to some volatility. So that is, they're just going to go into the air, evaporate quickly when the temperatures are quite warm. So always check the labels. If there is an upper threshold for temperature, follow that recommendation. I mean, it's there for a reason, and reason being, you're gonna get better bang for your buck if you follow those temperature recommendations, or you're going to see efficacy at all.
Jim and Meghan, thanks a lot for joining us here today on the Pest and Predator podcast.
You're very welcome. Thanks for having us.
Thanks, Sean.
I hope you enjoyed this episode of the Pest and Predator podcast. It's brought to you by Field Heroes, powered by the Western Grains Research Foundation. Visit fieldheroes.ca to learn how beneficial insects can benefit your farm.